somebody from AMD, and Google is actually going to show up, which I think is pretty darn cool. So if you want to go and show off what you made, or you want to learn a little bit more about what the software world is like, this is definitely a place that you want to show up. And I'm going to keep on reminding you guys about this for the next few weeks. So we're going to have definitely a good time with that. Hopping into the main meat of today's session. So today's session is a lot more of just going through more practice, getting more involvement. Today's session is primarily going to focus on enemies, but before that, we're going to go and do something. We're going to do a quick little problem solving. And well, I'm really doing this backwards a little bit before. That's just a quick review on that physics and collision stuff. Super useful. Oh, and Animal, thank you for doing that. Please take a look at chat. If you want to sign up for our Gala, we have a Google form plugged right there. I'll make sure that you guys get to see that again later. So first things first, let's go and make this a little bit easier for ourselves. I'm going to put my tea mug away so I don't spill it all over the place. So we are going to be mostly building on top of our game kind of stuff today. It's not required for you to do so, but it's just going to be so much easier. So if you don't already have your game set up, this is a reminder for you to go and grab it. What I'm going to go and do here is I'm just going to go grab all my folders here, and inside my game folder, let's see, I have it inside Ignite Sessions. I got my game folder here. I'm just going to take all this stuff here, my assets, my main, my platform, my player. I'm going to copy that, jump over into session number 6, and I'm going to paste that. But you know, I already have that ready to roll as well. This is just going to be for your convenience here. If you don't want to, that's a-okay. We'll just simply be coming back to that a little bit later. Alrighty then. Let's quickly chat about physics again real quick. So in physics, we have a couple of different concepts. We want to go and make things happen, and we want to make it realistic to a degree. So we're going to go and introduce some different variables here. The first one here, speed. This is how to go and make something march across the screen slowly. And notice we don't say ball.x plus equals 2. We instead say ball.x plus equals x speed. Inside the setup section, you define what your speed is. Inside your update section, you actually make it move. Or if you guys were following along what we did last week here, we decided that the best spot to be putting this would be really inside the player. I'm going to code this again just for you guys to review. You guys don't need to go and copy along with my code. I'm not introducing anything new in here. So inside our player, I just stripped this one down to its bare minimum. We got the initializer, we got our player image, and we got it all set up. First things first, when we are going to be talking about, we are going to want self.x speed, and we're going to set that maybe, I don't know, it's 5. We're going to go self.y speed. For now, I'm going to go set that to 0. And I want an update function inside my player. So I'm going to go def update, and I'm going to put in that first parameter self as usual. And I'm going to go and say self.move, self.x speed, self.y speed. And that's just going to make us slowly chug along. And for us here, we can save that. And I gave this thing an overly complicated name. You guys don't need to do that, but I'm going to go and quickly grab myself a main physics review. And I'm going to go from player physics review with a horrible name, import my player class. And a lot of this should look a lot or quite familiar here. So we're going to go player is equal to a player class, and I want to go and define it maybe at 200, 300. And I'm going to go and make my players group here. Players equals pygame.sprite.group. Make that, and then we'll go players.add player. Down inside our update section, we're going to go and quickly make that player follow along here. So we're going to go players, all of them, .update, even though there's only just one. And we're going to also do players.draw. And we go and pass in the screen parameter as well. If I coded it right, no guarantees on that. If I coded this right, we should get a player who's zipping along here. Excellent. Let's carry on to our next review topic here. This is going to be the concept of acceleration, and may as well make it actually acceleration that's realistic. The most common one that we all know about is gravity, the one where you fall down. Let's set our x speed to 0, our y speed to 0, aka nothing moves at all. We're going to go self.gravity is equal to, I chose a number 0.6 because I found it quite convenient. But if you want to keep it simple for your brain, just choose a number 1. Or if you really want to go physics fancy, you can go 9.81, blah, blah, blah. Back with 0.6, my convenient number here. I'm going to also add inside a fall function, def fall self, And inside here, I'm going to go self.rect.y, or oops, that's totally wrong. I'm going to say self.y speed plus equals self.gravity. With that, we should be able to make it fall. Of course, functions don't actually just come into existence. You actually have to go and call them. So self.fall happens inside our update function here, and we should be able to go and watch our guy plummet through the floor. Excellent. It is a great starting point here, and that is how we're going to go and do our acceleration. So carrying on to the next topic here, just remember acceleration is a gradual increase of speed over time. So it's your player is constantly moving due to speed, and that speed is constantly moving as well. Jumping is when you instantly bang, give it a quick sharp upwards y speed instead. So if we quickly go and plug that into here as well inside of our class, we'll go def jump. Keep ourselves nice and organized. And we're going to go self.y speed. Let's set it to equal to -20. That should be a nice satisfactory number here. And of course, we need to go and trigger that jump. I'm going to go over here, and my key presses, currently they're set up to nothing. You normally would have them for moving your player around. I'm going to make mine player.jump. And we give it a quick, sharp impulse upwards that only briefly happens, but boing, we can launch ourselves off into infinity. And I would say that is pretty darn fun. Okay, what is next? We want to quickly talk about collisions again. And so collisions here really is handled a lot by Pygame for us. So I don't have too much to go and code. But collisions, in short, is a little bit less intuitive because it's not continuous as the world we are familiar with. It is in discrete time, everything moves. Collisions is when two things overlap. We got a blue square overlapping with a yellow square. Or in the language of Pygame, it's when we have one sprite, like a player, interacting with a sprite group, like platforms or enemies. And the example here, I color-coded it. One player interacts with many platforms. One bullet interacts with many enemies. You can always flip the order around as you like, or interact and change it out as you see fit. But the important thing, overlap is collision. Standing on a platform here, if we take a look at this code, we say, which platforms have my player collided with? Well, my player has collided with the player here, excuse me, and anything inside our platforms group. And bonus, does anybody remember what this false keyword does? Okay. Do we have any other answers before I carry on? What does that false keyword do? Okay, I'm going to carry on. For those of you guys who don't remember, that's okay. This is just kind of weird. It's just how Pygame works. It does not delete the platform. So when false is there, it says do nothing with it when you have a collision. Do not delete the platform. It is the do kill parameter, if you remember the name. If you set it to true, it destroys the platform, not the player, the platform that you're currently colliding with. Keep that in mind because that's just going to be a small detail to pay attention to later. Anyway, where was I? Hit platforms. This is a list of all the platforms you hit. Technically, with a collision, you can hit multiple things at once. So if the length of this hit platforms is greater than 0, if we hit anything at all, I'm going to arrest that y speed. So my player is slowly plummeting down. We're going to say stop. Freeze in midair, please. Or more accurately, freeze on a platform. And we'll put this inside our player.update function to call it over and over again. So carrying on with the quick question. I want you guys to pay attention. There's a little special keyword here because that's a lot of spots to lose marks. But what does this code do? Let's take a minute to figure out. All right, last 5 more seconds to get those guesses in. Okay, keep on going. I want to see a couple more people getting their votes in before I close this off. All right, 5, 4, 3, 2, 1. Let's wrap it up right here. This one is a tricky one. The most popular answer you would think is that they'd stop falling and the platform is removed. The actual correct answer here is down into details. What actually happens is the player is, or the platform is removed. For those of you who are paying attention, yes, that platform does get removed. And the other part that happens is the player plummets down into an infinite spiral. Yeah, I know that one feels like a bit of a trick question. Admittedly, that one is a little bit weird. You have to keep on thinking about what happens next, because you're right, it does stop for a second. But then the gravity is turned back on. They keep on plummeting because there's no platform to hold them up anymore. So over here, I got the game version here rather than my nice little physics review. And we can take a look for that platform collision logic here. So down here for platform in here, I set that from false. I set that to true instead, just to make it so that the floor falls out from our player. And poof, we stop briefly. For those of you who saw that, that is correct. But we do keep on plummeting all the way down through the floor. So yeah, that one's a bit of a tricky one, but certainly is a good way to keep in mind. You got to be careful. You got to think through everything that happens. Now, getting some help 101 here, aka using internet resources. Why am I going to go and segue into how to use the internet? I mean, like, seriously, how many of you guys here know how to use Google? Seriously, I should be expecting a lot of hands to go up. How many people know how to use Google here? Yep. And I am seeing somebody has already basically stolen my punchline from me. The people who use Google the most are probably the programmers, because I will tell you, even though I'm the guy standing in front of you, theoretically teaching you all this stuff, I know almost nothing about programming, and I tend to forget about everything important too. Instead, I tend to go and Google everything. If I see an error message, I Google it. If I'm getting stuck on something, I Google it. If I just forgot how to go and use a for loop, I go and Google it. Google is seriously the best programmer's tool that you could ever have out there. But it's not very useful if you don't know what to Google specifically. You guys live in a world that's convenient. I'm going to give you a quick heads up though. Even though we are going to say the internet is your friend, the internet does have some nasty places out there. And from my perspective, where I'm actually studying a little bit of software security right now, it's a scary place. Some things to be cautious about. If there's any administrator prompts, is like, do you give this administrator access? Please pause. Just do not give it administrator access right away. You should think before clicking that OK button. Talk to your mentor. They probably would know what to do. If there's anything that says open up the terminal, run a script inside there. Again, take a moment, pause, and think it over. What is it doing? Yeah, there's a lot of useful scripts on the internet to run out there. There's a couple dangerous ones too. So please read everything carefully and completely before you run them through. And if you have questions, take a moment, pause, and ask your mentors here before you carry on too far. All right. Now the next part here, how do you guys Google? Not sure if I'm good at programming or just good at Googling. Honestly, the reason I'm actually pausing here is because it actually is a bit of effort to learn how to Google properly, because I've seen a lot of people, especially beginners, that try getting stuck and then they go and Google and they just get even more lost because they have no clue what they're looking at. And the internet, even if it's trying to help them, is not that helpful. So first step I'm going to tell you guys, go and add keywords. So for example, you're confused with sprites. What are you not doing fits? We'll see an example here. Help with sprites. Let's try Googling that and see what happens. Help with sprites. If I Google that, I get it. I have no idea what I'm looking at. You know what? Never mind. We're not going to go and do that again. But instead, if we want to go and get something, for example, put in the exact keywords what you're looking for. Put in common, well-known words like that is relevant to your conversation. Pygame sprites. Describe the problem you have. Put it in a nice, concise, simple sentence for that. That being said, you got to be careful. There is such thing as being too vague, as I just demonstrated, and there's also such thing as being way too specific about it. So if we say, make the player say ouch when touching an enemy, what happens when we try Googling that? I don't know. The players say ouch when touching an enemy. We get Scratch, we get other things, we got Unity. I don't know. I don't think it makes any sense for what I Googled here. And I'm not getting that ouch that I was actually looking for in the first place. So I think that the lesson learned here is you got to be careful about what you search for. Make sure you actually break it down. It's something that other people probably were searching for. How do you get ouch? Oh, that's maybe a question about getting sound effects in there. How do you touch an enemy? Well, maybe there's a keyword. Collisions may be the word that you're looking for. So take a look for something like Pygame collisions between sprites, and that would help you out as well. Of course, on the other hand, if you don't want to go and use Google outright, you can always use Pygame documentation. Pygame is fantastic for giving you deep dive details about how to go and use the library. So you get things like, for example, how does pygame.draw.rect? What are all the numbers that go inside there? I don't remember. Or how do I draw a circle or a line? Or what's the difference between like left click, middle click, and right click? These are all questions that Pygame's great for answering, especially when you're going to get down into dirty details. That collision one, like the do kill parameter, most people won't try covering that right away because that's not important to them. But maybe you do care. That is where you go and take a look at things like Pygame. That being said, if you're not quite an expert at programming, be careful. Documentation can be quite heavy because it's designed for someone who has a strong understanding of many of the different pieces, and it does not try to make a strong effort to go and connect them. Pygame sometimes has good docs, sometimes not. There's other libraries for other projects that have fantastic docs. Sometimes there's some that have terrible docs. So it is a bit of hit and miss there, but documentation is also your friend as well. But if we want to go and say, how does drawing a circle work? See, I can go and click this link here and I get the full details. I got this link called surface. I don't know what that is, but I do know that I need to go and plug it in. Oh, I got a description, draw a circle on a given surface. And hey, I got an example of how I go and write it out. I need to learn what these are, but I think if I combine this with Google, I can go and get into a pretty good spot with that. So I'm going to send you off to a quick question here. And this time, I don't know the answer off the top of my head. You guys are going to need to go Google it. What does this thing called getTix do? I'll give you guys 2 minutes to go search that up. Keep on Googling because in the meanwhile, I'm going to shout out the mentors. Go do your attendance. Last 10 seconds. And let's close it off right there. I apologize to those of you who do not have a high internet speed, but it looks like this one has been a bit of a landslide. Everybody, or almost everybody, has definitely gotten it. It's just going to be get the time in milliseconds since the program has started. So let's go and try it out here. If I don't know what that is, I'm going to just type it in exactly as I saw it. Pygame.time. get ticks, and well, I searched for it so many times it shows up here. But what do you know? Pygame documentation shows up first. Stack Overflow comes up next. Wow, there are plenty of answers I can get in here. And the most basic description is usually right there. Of course, I could click on it. I can get more details on how this works. For example, what happens if it's called before the game starts? It's going to be set to 0. Who knows? Maybe that's useful. And while I'm here, I might just look around. Hey, there's something called wait. There's something called delay, set timer. I'm not going to spend my time reading them, but it's not a bad idea to scroll through. Just find some documentation and keep that in your noggin, because maybe later that might come useful. Not for today's session specifically, but I found that when I was trying to learn how to program stuff, that was really useful for me. Anyway, more tips here. I'm not going to go over them too long, but if you're stuck and the solution you find does not work, be patient. Keep working at it. It is not always going to be easy. And read over everything. There might be some little minutia you missed to make it work. Maybe just try a new search. Maybe you realize you're a little too specific, maybe a little too vague. Go back to that last slide to review it. And finally, last one, if you're really stuck or just really having a bad time, get up, walk away. Okay, maybe that was a little bit too silly of a demo, but long story short, just go and do something other than staring at your computer screen. Honestly, take some deep breaths, go get some exercise. It does wonders for your body, and it therefore feeds into your brain directly. Anyway, I think that we covered all of the fundamental stuff. I hesitate to call it boring because it's extremely useful, but let's jump onto a little bit more of the fun stuff today. So we're going to go and start talking about an enemy. An enemy really is just following along with a lot of the same stuff that we have been doing in the past. So we're going to go and create our own enemy sprite. It's going to be quite similar to the player, but this time around, we're just not going to have any keyboard controls for it. First things first, let's go grab the image. I got the image ready to roll right here. I'll go and drop that into chat, and you can save that as enemy.png. I click that, save image as, and you can just save that as enemy.png. And you can see I got a ton of pictures downloaded already. Okay, awesome. And I'm going to be coding this file from scratch, but really it is just quite similar to the other sprites that we have seen before. I'll go create my new file, and I'll call it enemy.py. And we'll go to the classic import OS, import Spark, or that, wrong thing, Pygame. And we'll go class enemy, capital E on there, pygame.sprite.sprite. Okay. And inside here, we're going to go with our classic stuff, the initializers, def double underscore init, double underscore cell. Let's also toss in an X and a Y parameter, because that's quite similar. We're going to go super open bracket, close bracket, double underscore init, double underscore open bracket, close bracket one more time. And we're going to go image location is equal to os.path.join, and take that image, drop it into your assets folder over there. And we're just going to go and plug it in as usual, assets, comma, and then we're going to go enemy.png. Off to the races we go. We're going to go self.image is equal to image.load. I hope I have my parameters right. Image location. We're just going to pop in that usual thing, that convert alpha that we just memorized, and self.rect is equal to self.image.getRect. And honestly, next time we should use inheritance to make this faster so that we don't have to type out all this code from scratch. But we're not there right now. We're just going to stick to the basics. Self.rect is equal, self.rect.x is equal to x, self.rect.y is equal to y. And we go and confirm that we have gotten that working. Okay, inside our main class over here, we're going to go from enemy, import enemy, and we'll go and create ourselves some enemies as well. I'm editing this straight inside my game file here, not inside my main physics review thing. And I'm going to go with enemies is equal to pygame.sprite.group, open bracket, close bracket there. And we're going to go enemies.add, and then we're just going to create an enemy right on the spot here with a capital E, enemy. And let's plug in some X coordinate, Y coordinates. All right, then. If I was good at math, I would know where to put these things so that they're not flying off in midair. But I'm not, so I'm going to go and just simply take some random guesses instead. So I'm going to put that at coordinate 300, I'm going to go and set this at 550, and then we'll leave it at that. And I'm going to take this line, I'm going to copy paste it. I'll have 2 enemies. Sure, why not? That sounds like a great number for now. I'm going to set this one maybe at coordinate 700, and I'll go and set this link to be hanging out at coordinate 400. If I'm lucky, I'll be putting it straight on top of a platform. If not, it's going to be floating in midair. Oh well, we'll live with what we got. Down inside the update section, nothing terribly out of the ordinary. Underneath players.update, I'm just going to go and add in here enemies.update. And down inside my draw section, the same deal, players.draw. I'm going to add underneath enemies.draw screen. I know I was typing fast there, but that should be all the typing. I'll press play just to confirm it works, and perfect. Well, we got these guys kind of floating around in midair, just a couple inches off, but otherwise I think that looks good. How are you guys doing? Does anybody need me to go back and show off some of the code that we just typed? Okay, no worries. Inside the class enemy here, our Pygame sprite, we just got the initializer here. We copy paste basically most of this all the way over from the player style here, and then we just swap out player with enemy. It's basically the same deal here. Once we go and copy paste the image location, self.image to self.rect and self.rect.x, self.rect.y, we're going to jump back into the main file. We'll go from enemy, import enemy, and we'll go enemies equals pygame.sprite.group, and we'll plug them in. And just because I'm here, I might as well add a little bit more. You know that they're about 40 pixels tall. So if I do that, add 10 more pixels onto my dimensions, they should be a little bit better. Enemies.add, open bracket, another enemy, or enemy, open bracket again, plug in some coordinates, close those brackets twice, copy paste that line as many times as you need, and if you're good, dropping them on top of your platforms as well. Down here inside your update section, enemies.update, and then we're going to do enemies.draw. It's just a lot of the same routine. Hey, okay, I think that they look a lot better here. They are finally able to go and stand on solid ground. Moving on to the next part here. We need to go and implement, oh, I skipped ahead. We already have done that slide here. And let's go talk about getting some of these things looking a little bit better. If we take a look at this enemies, they are currently kind of standing in a little bit of a funky spot. Here we go, I got my screen. So that one's facing towards me, that's good. This one's facing the wrong direction. And if you notice, they actually load up at the default size of the image itself, which has been conveniently scaled down to 50 pixels wide and like 38 pixels tall, if I remember the numbers correctly. But if you ever tried Googling your own image off the internet here, and you can go like with a sprite or pixel arts enemy, if you take a look at this, most of these are huge. This one here is 320 pixels by 320, which maybe this is just a simple small enemy in the player's imagination. But if you try dropping this into your game, it would look like a ginormous boss battle. I mean, that would be super cool, but I think that if you want some control over it, you need to go and scale them properly. You know, why not? Let's go make this enemy a little bit bigger. We're going to use the scale function on this here. So how about we go and take our image, and we can go with, inside our constructor here, I'll go self.image is equal to pygame.transform.scale. What am I scaling up? I'm scaling up the same image, self.image. What size do I want to make it? I'm going to go and plug in the x coordinate and the x width and the y, the height. So maybe I want it to be 100 wide, and I'm going to make it 80 tall. And with that, we first set the image, which is just loaded up, take that image, plug it in, perform the transformation on it. What's kind of interesting to pay attention to is that the image itself is not being replaced, but it's actually simply being altered as a copy. And then I say, finally, please replace it over here. And I say 180 as a good old tuple to go and plug in the coordinates. Let's go and press the play button on this real quick. And whoa, hello. These guys are ginormous now. They're just kind of sitting inside our platforms. I think that looks pretty cool. It's a great start, I'm going to admit. But let's keep on going with this. Perhaps we want to go and flip them around. I'm going to go self.image is equal to pygame.transform.flip. Which one am I flipping? image again. And I want to say on the x-axis, do I want to flip it? Yes or no? Yeah, I want to flip it on the x-axis. How about the y-axis? So last time was this way. How about, do we want to flip it that way? No thanks. I want it to face left and right rather than up and down. So doing that, I can go and get it to go and flip. And they're now facing the opposite direction. Let's go and close off our random Google searches here, just so that you guys can see the slides here. One more time. Self.image is pygame.transform.scale. What are you scaling? The image. You take this little small one here, plug it in, tell the new size. Or you can pygame.transform.flip, set in the image. Say the x-axis, I want that to be true. Or how about the y-axis? Probably not. I don't want to do that flip, so I'm going to set that to false instead. And just as a little bonus, I'm going to show this off because this might be useful for those of you interested in doing our bonus activity here. I'm putting self.image and self.image in here, but this is a destructive property, or it mutates the image, permanently transforming it forever. What if I went with something like, I'm going to call this thing, instead of self.image, I'm going to call this self.baseImage. I can make up whatever name I want. The sprites just simply are looking for image in particular. And I can say self.baseImage is going to be, or self.image is the scaled up version of the base image, which actually, you're not going to see the effects immediately. All you're going to see is that it is just transformed as you expect, but the base image is still the same. The base image is still that tiny guy facing to the right, whereas these other ones here are the main image is flipped around. Why is that useful? You're going to have to come back to that. That's part of the bonus challenges. I don't want to spend too much time on that. That being said, though, let's carry on. Let's make our enemy walk around. This is actually not terribly difficult to do. What we want to go and do with making our enemy walk is basically a lot like what we've done in the past with the player. So I'm going to go make a move function, def move, and I'm going to go self, and I'm going to go put in my x change, and I'm going to put in my y change. And this should feel very familiar to you guys at this point here. Self.rect.x plus equals x change. Self.rect.y plus equals y change. We're just simply going to say, put in some amount to change it by and make it move by that. Nothing surprising. But now we can have some a little bit more fun with this. We're going to go def and update. Remember the update function we never set up yet? This is where we're going to do it. And I'm going to say self.move. And then I can go and just simply plug in here my x change and my y change. Let's say 2 pixels to the right and 0 pixels up and downwards. If we press play on that, boom, and we got our go live sliding off. What I'm going to do here, I'm just going to go quickly disable this stuff. Self.baseImage, sure. I'm going to just simply cheat this entire thing. Self.image is equal to self.baseImage. So please just copy that reference here. Take these 2 lines of code here, Control/, and comment them out. I don't want to deal with them right now. And you know what? Last part here, let's clean up the code. Self.xSpeed is equal to 2. Self.yspeed is equal to 0. And down here inside my update section, instead of just hard coding 2 and 0, I'm going to go self.xSpeed and self.yspeed. With that, we can make our enemies start to march around, marching off and, okay, and, okay, bye, see you guys later. No, never mind, that didn't quite work as intended. All right. Obviously, our enemies are not quite up to snuff yet, but instead of me telling you how to go and fix that, how about we get you guys to do it? How do you make it so that every 2 seconds, the enemies will change direction? For now, focus on making the enemy travel to the right. 1 second later, flip around, go on the other direction. 1 second afterwards, you can worry about flipping its direction again. And for those of you guys who were following along with what I said with the base image and the flipping and stuff, maybe you can actually make the enemy look a little bit more proper rather than gliding backwards. How about I give you guys 15 minutes to get started on that? Let's roll. With that interruption. So I apologize, and I'm going to try to make it back right now. What I'm going to do, I'm going to set up myself a walk function over here in my answer. Rather than trying to update my or edit my update function directly, where there's some complicated logic going on and it's going to be annoying to handle, I want to go and set up instead my own walk function down here. And all I have to do is go self.walk. Theoretically pretty simple, but how does walking work? Let's go and take a look at how we go and make our enemy pace back and forth. First things first, I need to go and figure out, well, when is the, or if I want to go and check how much time did pass. I said that 1 second go to the right, 1 second go to the left. So we'll just start nice and simple. For now, assume we're going right, and if 1 second passes, we'll go to the left. So what does that look like? We're going to say if igame.time.get ticks is greater than, and we're going to say 1000 milliseconds, aka 1 second here. I want to go and say self.xspeed is equal to -2, which is fantastic to start with. Let's get that rolling. And we got our enemies that take 1 second to go forward and they march on offwards off to infinity. So we're going to need to go and get that a little bit more creativity in here. So what I'm going to go and do here is employ a good old math trick called the modulo operator. There are multiple ways to solve this. I personally find that modulo is really cool because we can do remainders. So if we take 2 seconds, or if we take the total amount of time that passed, so maybe 1 second, 8 seconds, 27 seconds, and we divide that by 2, and then we take the remainder of that, we can go and say, hey, was the remainder less than 1000 seconds or more than 1000 seconds? So let's go and do that. I'm going to go and say igame.time.getTicks modulus 2000. Is it greater than 1000? It says, let's define that. If total time divided by 2000 milliseconds is has a remainder greater than 1000 milliseconds. So if it's greater than 1 second, so that's going to be from 1 to 2, from 3 to 4, from 5 to 6 seconds in there, we're going to set the speed to be negative. Else, we're going to say that this is from 0 to 1, from 2 to 3, from 4 to 5. We're going to say that we want to go and set our traveling to be equal to the right instead. Oops, and I cannot run the enemy file, so I'm going to run that main file. And now we got him jiggling in place, which is, I think, a lot closer. And we've got a nice little moonwalking effect. If we want to go for that bonus challenge, what I'm going to do here, I have this base image already set up and ready to go. What I can also do with here is I'm going to go self.leftImage is equal to pygame.image. Pygame.transform.flip self.baseImage. And I say true to this X dimension and false to the Y dimension. And for now, I'm going to say the base image, the right image. And I'm going to say down here, when I'm traveling to the right, which is a positive number, self.image is equal to self.baseImage. How about when I'm walking to the left? Self.image is equal to self.leftImage. Those are not fantastic names, but I think that these should do for the time being here. And now we actually have these images that have been stored. There's a base image, there's a left image, and now there's also the image that you're finally seeing here. The self.image is the one you're familiar with, and we're just loading in, we're swapping in. The image is now the base image, the image is now the left image, and we're going to flip it back and forth every 2 seconds there. So that's how we're going to cover the bonus. Let's keep on moving. When we take a look at enemy collisions here, collisions basically is along the same theme as what we did last time. So what happens if we got an enemy who collides with you from the side? What happens if you want to jump on top of them? You can do a multitude of different combinations here. And really, this is a lot of just repeating the same logic we had before. This time, though, the only difference is we got 2 things that are moving. But how are we going to know if we jumped on top or ran into the side? After all, that collision function doesn't tell us much. It tells us who collided, it tells us where they are, and you could use the classes and objects to get more details. But it doesn't give you much more. You're going to have to use some creativity here to figure it out. Let's get the easy one started. Let's have that enemy run us over. So if our enemy collision, if the length of that hit enemy is greater than 0, if there is one at all, player.kill. Let's go and murder our little player, which is an unfortunate ending, but that's how games go, okay? So we're going to go hit enemies is equal to pygame.sprite.sprite collide. First one's going to be the player, just one player. And then we're going to have a lot of enemies. So we're going to go with enemies in here. And we're going to say false. We don't want the enemies to be murdered here. If the length of the hit enemies is greater than 0, I'm going to say player.kill. So if there is any enemies at all that hit us, or we hit them, or whatever you want to call it, they're going to go and flat out murder us. So I'm going to jump in here, poof, game over. I mean, it's really good if you want like some dangerous spike traps or something in your game, but let's go and say we want to bop them on the head instead. So bopping them on the head, what we can actually do is we can take the exact coordinate where they are. This is not the perfect algorithm, but it's a pretty darn simple approach for it. We know that we have a bunch of enemies, and if any of them collided, we want to kill the player. But let's go revise that. I'm going to go and take this code, and I know we just wrote it, but I'm going to delete it. I'm going to say for enemy in hit enemies. So that'll tell me which enemy I'm currently colliding with. Usually that's a list of one, pretty darn simple. And I'm going to say, if my player is above the enemy, then we're going to go and consider that a collision. Above is going to technically mean a little bit inside because we're already hitting there. And if that's the case, we're going to go and kill the enemy. Notice I'm going to keep this false because I don't want to automatically kill the enemy regardless of scenario. I only want to kill them sometimes. So I'm going to say if player.rect.y plus player.rect.height is lesser than enemy.rect.y, and then I'm just going to give a little margin of error where it can go and collide. I'm going to say plus 10. If we have that set up here, then we can go enemy.kill. And heck, you know what? I can even have some fun here. I'm going to say player.jump, forcibly make the player jump out as well, make him feel like a little bit of Mario spring action happening here. Else, if that's not true, if we're not landing from above, clearly means we're coming from below or on the side or any other direction here that doesn't play as nice. We're going to go and say player.kill. Heck, I wish I had a really cool animation for that too. But you can do player.kill. You can also like take damage there if you go and create that. And we got our enemies dancing around. And let's check. I'm going to hop. And oops, you know what? I'm going to hop for this one over here. Suddenly I'm playing. Oh, well, we at least confirmed that sideways killing works. If you guys don't know, I'm terrible at video games. Dang it. This is a terrible example on my behalf here. Wow. You know what? I'm going to just simply go and leave it to this sprite to go and show it for me because I'm not going to embarrass myself with video games any further. What we got here is the player. If they come charging in from above, we got lesser than or equals to what 1 pixel. It's going to be not very much of a difference here. We're going to go and tell the enemy to get killed. I wish I could show off that Mario bounce, but today I am bad at video games. Go figure. I can't even play video games anymore. We're going to also keep this as false. Just a reminder, we don't want to instantly kill the enemy, not until we at least confirm that we have actually hit it. Okay. You know what? I'm going to tell you something now. I am done teaching you new stuff. That's it. We have finished the Shoelicking Night stuff. But what about session number 7 and 8? That's where it's time for you guys to go and start building up your own game. This is a time for you guys to actually start to shine. And we're going to give you some bonus time in session number 6. So build up your game. Go anything you want. But just a reminder that it's going to have to stay simple enough. We got 1 month till the gala. And so while I see some of you guys are super excited about building this stuff, make sure that you can build it. My rule of thumb, think about what you can get done for the gala. Just take an estimate for your own skill there. Then take that time, cut it in half, just to be on the safe side. Use half that time just to go clean up and get rid of all those weird bugs in there. And anyway, you can build, what kind of games do you guys want to build? You guys can build anything you want. You guys don't have to build what we just showed you. You don't have to use that little purple player. You don't need to use the platforms, those little red enemies. Throw it in the trash if you don't want it. If you do want it, hey, there you go. They're already built right there for you. You can create anything you want. So do whatever you want with that. And you guys have no game inspiration right now. Research some games for you to be inspired by. Go choose something with that. Have some fun with that. And of course, I get an opportunity to plug the gala. The gala is where you get to show off the game and where everything really cool is going to be happening. And as you guys have probably heard, and I'll be reminding you guys again, we're going to have some really cool people there. We got Cisco, we got Benevity, we got Google coming in. And if you're not impressed by that, I don't know what will impress you. And this is some really cool opportunities to learn what did they do and what have you provided that maybe they are inspired. Maybe they can actually go and hire you. True fact, I've actually been doing something quite similar. I was doing a competition and I got hired by Cisco because of it. And anyway, registration link. I need to update this message here as Animal has been certainly posting in the past little while here. The gala is right here. Go and join it right now. I definitely recommend it. And if that's not enough, I'm going to go and remind you just one last time. Remember all those Ignite points you guys been accumulating? I see that attendance is fantastic and the top 10 winners or top 10 runners have the exact same score for attendance. Bear in mind that the score The quick questions are not tallied in yet, but the games are also not tallied in yet. So if you're going to go submit a game to us, and if you want to go and get one of those sweet $10 gift cards here, send it to us before April 15th. We'll get it ready to go and show it off to the gala. And our favorite 3 games they're going to get 100 points. That's more points than anybody has actually gotten so far. I checked the scoreboard just last night. I don't have a formal set of rules yet. I will be coming with them. But I'm going to say, must use Pygame. You must have created that code during our sessions or anytime afterwards. So no, you're not allowed to reuse an old game you made from before. And you need to submit it. If you don't submit it, we can't mark it. And that deadline is pretty darn strict, April 15th. We are not making exceptions for that. So make sure you get it in there. Finally, how do you get the best game in there? Well, you're going to have to make one that's creative. So one that's obviously fun, one that's really shows some cool stuff. Something that obviously pushes your difficulty a little bit. And make it well designed. I don't want to read spaghetti code. I read too much spaghetti code that's my own. So I would rather see something really cool. I'll be creating a better set of rules that you guys can follow later and so go and take a look at. But remember, top 3 gets 100 points. And then from whoever has the most points afterwards, top 3 of those people will get some sweet gift cards. All right. Before I release you guys, there's a couple things I want to say. One, before you start your game, please talk with your mentor about it. Let's make sure that you guys are building something that is within your grasp. And then number 2, Animal is going to go and release the poll again, just to see how this session goes. Because we're done here. You guys don't need me to go and show you your games anymore. Okay. I think that is everybody has given an answer. Thank you very much for that. And yeah, I'm just going to plug myself here. I created this thing over the last couple of weeks while simultaneously using this to go and build up examples for you guys. If you guys want to learn how I built this link, feel free to chat up with me anytime or go hang out with your mentors. Your mentors probably have some really cool things to talk about. That's it from me. How about you guys go have some fun?